Now let's look at the counter. This is Modulo-12 counter. It's going to count from 0 to 11. Once it reaches 11, automatically it becomes 0 again. And there is a load signal. Whenever you activate load, whatever the data you place at the data input, that will be stored in the counter. And from that value, the counter is going to increment. It's a loadable counter. You say 4, then the count is going to be like 4, 5, 6, 7, increment like this. And there is a clock, active high, reset, active high, and output. Module, loadable counter, name of the module. Within port list, you define all the ports, inputs, clock, reset, load, input, data, 4 bits, output, reg, count. So here I'm defining output as reg because I'm planning to use always block. Here the reset is synchronous, so I'm not going to include reset as part of sensitivity list. It's a synchronous reset. So when I say synchronous, the entire logic depends on clock. Everything is going to be under the control of clock. So always at passage clock, if reset is high, you reset the device, counter is going to get 0. Else if you check the load, if the load is high, then you store the data in the counter. So whatever the data you are going to keep, the value will be stored in the counter. Else if counter reaches the maximum value 11, the counter should be reset to 0. So there is no reset, there is no load, there is no maximum value, then the counter should increment. This is how you can define the functionality. When it comes to counter, you need to understand the control signals. You need to understand the priority of the signal. Here, the reset has highest priority, then load, then modulo value, then finally count happens. For example, at the passage clock, if there is reset, it will reset the device and it will come out. That's how it's going to work. Next time, at the passage clock, if there is no reset, you deactivated it, then it checks, is there any load? Okay, there is load, then the counter will get the value and it comes out. Then in the next clock edge, you deactivated the load signal, then it will check for modulus value. Okay, it hasn't reached maximum value, then it will go to count operation. For example, you loaded the counter with 5, then as per the count operation, it will become 6. Then in the next clock cycle, 7, 8. That's going to happen. Once it reaches 11, let's say it reaches 11 in this clock cycle. Then in the next clock edge, it comes inside. Is there any reset? No. Is there any load? No. Whether the count has become 11? Yes. In the last clock cycle, it has become 11. So I have to make it 0. Then it comes out. So that's how you need to visualize. This is how you can implement a loadable counter.
Thanks for watching this video. Thank you.